Hello friends, welcome to another video, and this question is asked in May 2011 BEE paper, and the question says each of a star connected load consists of a non-reactive resistance of 100 ohm. So it is given that the non-reactive resistance of 100 ohm in parallel with capacitance of 31.8 microfarad. So you can see in our diagram, uh, the resistance, that is R, is parallel with a capacitance C. Okay, so this is how our circuit is going to look, and they want us that the star connected circuit should be looking like this. Okay, the further detail they are not given, just they asked to calculate the line current, power absorbed, the total kVA, and the power factor when connected to 416 volt 3 phase 50 hertz supply. Okay, so the total line voltage of 416 volt is given to us. Okay, and the frequency of that voltage is 50 hertz, which is also provided to us. Okay, and what they ask is to find a line current, power absorbed, and kVA and power factor. Okay, so first of all, I want to tell you that how you can find a line current. Okay, remember in star network, this is our star network. Okay, so this is our three phase star network. Okay, this is a neutral. Okay, in star network, you know that our line current, that is IL is equals to phase current IPH. Okay, so knowing this, if I want to find a line current, okay, that is this current flowing in this circuit, okay, between these 2 points. Okay, so I need to find VPH, that is phase voltage. Okay, by knowing phase voltage and knowing these two values, I can easily find the current in this loop, or sorry, in this branch. Okay, so the first thing I need to find over here is VPH, that is phase voltage, which is not given to us. Okay, they have given the total voltage, that is 416. Remember, this is not a phase voltage. 416 volt is the line voltage. Okay, to find the first thing I need to do is find the phase voltage. The second thing I need to accomplish is to find the capacitive reactance. Okay, because we are being provided with the capacitance of 31.18 microfarads. Okay, I cannot use the capacitance value. I need to find the capacitive reactance, that is Xc, and to find the capacitive reactance Xc, the formula is just 1 upon 2 pi Fc. Okay, so I will find the capacitive reactance, I will find the phase voltage. After that only I will go for finding a line current, power absorbed, total kVA, and all that stuff. Okay, so without wasting time, let's begin with our first finding, that is phase voltage. Okay, so the first thing is VPH in three phase circuit. Okay, in three phase circuit, you must knowing that the phase voltage, that is VPH, is given by, is equals to VL, that is line voltage, upon root 3. Okay, so the line voltage, that is total voltage, is given to us, that is 416 volt upon root 3. Okay, by evaluating you will get the phase voltage of 240.18 volt. Okay, so the phase voltage, that is VPH, is equals to 240.18 volts. Okay, this is my phase voltage. Remember that. The second thing we need to find is the capacitive reactance, that is Xc, and it is given by 1 upon 2 pi Fc. Okay, by substituting the value we know all the values, that is 1 upon 2 pi is constant into frequency is 50 hertz, it is provided to us in our question, that is 50 into capacitance is 31.8 microfarads, that is 10 raised to minus 6. Okay, so this is our uh, uh, capacitive reactance, and it is given by xc is equals to, by evaluating this all you will get the capacitive reactance value as 100 ohms. Okay, so this is my capacitive reactance. Now I am able to find whatever they ask me. Okay, so the first thing I need you to solve or need you to find is what they called as power absorbed. Okay, power absorbed. So the first thing we will find is the power absorbed. Okay, and you know there are many formula to find the power, but I am going to use this formula which is very easy and very less time consuming, that is V square upon R. Okay, power absorbed is V square upon R. Remember, this power is the power in only one branch. Okay, so the I will I'm finding the power absorbed in this branch. Now by multiplying with 3 I will find all the power consumed in all other two branches. Okay, so what I will do in this formula, I will just multiply this with 3 to get the total power absorbed. Okay, so what is V is just Vph, not the whole VL. Don't use the value of VL, we are using the value of Vph because we are finding the power absorbed in one branch. Okay, so this branch, then multiplying with 3 I will find all other powers in this branch and this branch. Okay, so the value of voltage is just the phase value. Okay, the phase voltage value, so we are using Vph square upon R into 3. So the power absorbed is equals to the value of phase voltage we just calculated over here, 240.1818 volt. So I will substitute that 240.18 the whole square upon 100 into 3. Okay, so by evaluating you will get the power absorbed as P is equals to 1729.4 watts. Remember, this is a total power absorbed. Okay, so this is the answer. Okay, after finding the power absorbed we will find the line current. Okay, so the fourth thing which we going to find is line current. Line current. Okay, so here I want you to use a very interesting formula on which I am working, and I found that this formula is very helpful for finding the line current in only one condition. Remember when to use this formula, that is IL, the total line current is given by twice of Vph upon under root R square plus XC square. XC square. Okay, so we are using this formula and why we are using this formula, let me tell you that when you find this type of circuit, okay, so this is your R, this is your XC. Okay, to find the total current, that is IL or line current. Okay, so this is my input and I want to find this current, I will use this formula. Okay, this formula to find the total current. Condition is that the R and XC value must be same. Okay, so we use this formula only when the R and XC value is same, and you can see that our R value, that is resistant value, is 100 ohms, and our XC value is also came out to be 100 ohms. Hence I am using this formula to minimize my major calculations. Okay, so the IL is given by 2 into VPH, that is the phase voltage is 240.18 upon under root R is 100 square plus again 100 square, XC is also 100. So by doing this I will get the value of IL, which comes out to be 3.396 amperes. Okay, so this is my line current. Okay, and its value is 3.396 amperes. So I found my line current, I found the power absorbed. Now I required to find is the total kVA. Okay, so I am finding the value for kVA, that is sixth one, kVA. Remember what is kVA? kVA is nothing but the apparent power, and the apparent power is given by V into I, is the formula of finding apparent power. Here what is V? That is VPH, remember, into I. What is I? That is IPH, that is phase current, into phase voltage. Okay, what is the value of phase current? So the apparent power S is equals to phase voltage is 240.18 into what is the value of IPH. Okay, you can see we have not find the value of IPS, but I have the value of IL, which is line current. Okay, you know that, which I mentioned early in this problem, that the line current and the phase current are same in a star network. Okay, by using this knowledge we will substitute the value of phase current, that is 3.396. Okay, remember this is this is just finding the power in only one branch of your star network. Okay, so I am finding the power only in one branch. Again, to find the power, total power, I need to multiply its answer with 3. Okay, to find the power in all branches of star network. So by multiplying 3 I will get the answer as 2446.95 VA. Okay, so this is my apparent power which they want us to find, and we have just found that. The last thing is to find the power factor. Okay, power factor. So what is the formula for power factor? You know the power factor is given by cos phi, but did I provided with the value of phi in question? No, so I will not use this formula. I have another formula, okay, which will give me the answer, and the formula is kW, that is total power or active power, upon kVA, that is apparent power. kW is active power and it is represented by P, and the apparent, that is kVA, is the apparent power and it is represented by S. Okay, so to find the power factor I just need to take the ratio of total power, that is P upon S. What is total power? I just found here the total power. As you see, this is my P value, which is a total power, that is 1729.4 watt, and the apparent power which I just found over here, that is 2446.95. Okay, so taking the ratio of these two powers I will get my power factor, that is PF. It is given by 1729.4 upon 2446.95. By solving this you will get the power factor value, which comes out to be PF is equals to 0.7067. Okay, so this is the value of my power factor, and this is the end of our question. Okay, so I found all three value which they asked, that is line current, power absorbed, total kVA, and finally the power factor. Thank you for listening.